Hello, Algebra students. Mr. Lawrence here, and I'm trying a different headset. Hopefully it'll come out crystal clear for you, but we're going to give it a try and see what happens. So, first of all, we have a plane flying 1,300 miles in 10 hours. Missing an S there. Against the wind. The return trip takes 13 hours. What are the speed of the plane and the wind? Well, first of all, I want to know the speed of the plane. That's P. I don't know. It's against the wind. Uh-oh, I have a mistake. I have a mistake here. Yes, I do. Let me fix that really quick. The 10 hours should be with the wind. How did I know that? Well, 10 hours with the wind, because it would have to be quicker, right? The with the wind trip should take less time. Okay, so now I've got that fixed. Now I have other technical difficulties. Oh dear, oh dear, oh dear. Let me try this. Oh mouse, why have you stopped working? There we go. Okay, so looks like we're working. So I've got the speed of the plane, and the wind is aiding it, increasing it. And then remember, I've got speed is the distance divided by the time. Alright, well the distance is 1,300 miles, and the time is 10 hours. So this equation really becomes P plus W equal to 130. Right? Now, the return trip, the wind is hindering me. So I'll have 1,300, and it's taking 13 hours. And so that equation simplifies to P minus W, and that'll be 100. So now I can solve by elimination, add together, I get 2p, w's cancel, and I get 230. Okay, and so, you know, half of 22 is 11, and half of 24 is 12, right? So half of 24 is 12. If I had half of 23, I get 11.5. That's interesting. Why would I be talking about that? Because, 230 divided by 2 is 115. 11.5, 115. Coincidence? I think not. So, P is going to equal 115. So the plane is traveling at 115 miles per hour, right? Okay, now I should figure out the speed of the wind, and I will do 115 plus W equals 130. I'll subtract 115 from both sides, and then W equals 15. So the wind is blowing. You don't usually think of the wind as traveling, although it does travel, I suppose, blowing at 15 miles per hour. This must be one of the smaller type planes, not a big passenger jet. But there you go. Now let's do one where the numbers aren't so friendly. We've got a boat traveling 200 miles in 35 minutes. Well, this is a distance, right? Distance. And this is a time. The problem is this time is not in hours. So I'm going to take 35 minutes and divide by 60. That will give me the percentage of hours. And so 35 divided by 60 is the same as 7/10, which is 7/10. So for my time, I'm going to cross that out, and I'm actually going to write 0.7 hours. Hopefully that helps you out. I know this was bothering Derek a little bit. Maybe crossing out the 35 minutes and replacing it with 0.7 hours, that will help. Now we're going to do the same thing down here. The return trip takes 45 minutes. Well, let's see, 45 over 60 is 3/4 of an hour, or 0.75 hours. So I'm going to get rid of the 45 minutes, and I'm going to replace it with 0.75 hours. And hopefully that will help you. Alright, so I've got a boat. it's going downstream, so the current is helping it. And I have to do the distance divided by the time, the 200 divided by the 0.7. And then I have a boat minus the current, and it'll be the same distance, and this time it'll be divided by 0.75. And so my equations turn into this. B plus C equals, and B minus C equals. And if you don't want to do that, you want to go to a calculator, that's fine. I'm going to go with 200 divided by 0.7. And that will get me 285.71. So let's see here. This will be 285.71. Okay, and then I can do 200 divided by 0.75. And that'll get me 266.67. All right, minimize that. Solve by elimination. I'll get 2b, and that will equal 8, 3, carry the 1, 2, carry the 1, 5, carry the 1, 5. And then I'll have to divide by 2. All right, so I'll go 552 and 38 hundredths divided by 2, and we'll get 276 and 19 hundredths. So, the speed of the boat, 276, oops, I forgot it already, and 19 hundredths. Right? So, the boat is traveling at, let me move this over, at 276 and 19 hundredths miles per hour. Okay, the current is traveling at okay, so let's see here. D plus C, so we have 276.19 plus C, and that equals 285.71. So I'm going to subtract 276 and 1900s from both sides. Okay. And so I'll get the speed of the current, and let's see, that's going to be a 6. And so we're going to get a 2, a 5, and then I think that's going to be 9. Yeah. So the current is traveling at 9 52 hundredths miles per hour. And that should be it. All right, we're going to do one last example. And this time we have two trains which are 640 miles apart. Unfortunately, they are on the same track and heading toward each other. First train is traveling at 30 miles per hour, and the second train is traveling at 50 miles per hour. How long will it take for the two trains to collide? Now, I'm going to do this a 6th grade kind of way, 30 miles per hour, and I'm going to do this an algebraic way. Now, I think you'll see the algebraic way works better. Okay, so what I'm going to have is I'm going to have train 1 and train 2. Okay, and then the distance, well, this would be the distance of train 1, the distance of train 2, and then the distance remaining. Okay, so I'm going to see if I can figure out when they actually collide, kind of by making a chart and figuring it out. Okay, so let me see, I'm not sure where my pen went. Okay, and so after 1 hour, oops, not sure what just happened there. Okay, so after 1 hour, The first train's going 30 miles per hour. I might write that up here, 30 miles per hour. Second train's 50 miles per hour. And then the total distance was what? Was it 640? Yeah, 640 miles apart. Okay. That'll be 30. It's gone 30, and this one's gone 50. And 640 minus 8 would be 560. Okay. So this one's gone 30 miles. This one's gone 50 miles. There's 560 miles up. After 2 hours, I get some divisions here. All right. I'm not sure how many it's going to take. I might need more than that. So these are the purple numbers on the right, or on the left, excuse me, are the hours. So 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. We'll see if I need to do more. So after 2 hours, the first train has gone 60 miles. This one's got 100 miles. And this one's gone another 80 miles, so I should be at 480. Okay, and then, yeah, that's right. And this one's gone 90 after 3 hours. This one's gone 150. And so I've lost another 80 hours, haven't I? I lost 30 here and 50 there, so that's 80. So this will be down to 400 miles. So after 3 hours, you're still 400 miles apart. Okay, 120, 210, no, 200. Okay, and so that's 320. The original was 640, so I'm going 320 miles. Okay, now I'm guessing it's going to be 8 hours because at 4 hours, they've covered half the distance. So I'm assuming that after 8 hours, they're going to have covered the remaining half of the distance because the rates aren't changing. So let's see here. I can't see. There we go. 7, 8. I'm guessing that I'm only going to need 8 spaces total. And again, this is the long way of doing this. We're not going to do this in class, but I think it's good to understand. Okay, so we're going to go 150. We're going to go 180. We're going to go 210 and 240. Okay, these will be 250. This will be 300, 350, and 400. And right here, you notice these two numbers are 640. So there would be 0 miles left. So it took 8 hours. Now it took a long time to do. Now, if you want to stop and figure this out on your own, go ahead and pause the video. See if you can find a better way to figure it out. So we would stand to reason that these two trains are going to intersect, not in the center, but maybe somewhere over here. Because the green train is going at a slower rate than the orange or peach or whatever color that is. So they're actually going to collide with each other, say right here. And I'm only guesstimating, right? Now, the two trains, one traveling 30, one traveling 50, have covered 640 miles in 8 hours. I wonder, what speed would a train have to be traveling to cover 640 miles in 8 hours by itself? Well, the time up here, time was 8 hours. I'm going to use my D equals RT equation. Let me get out of this yellow here. D equals RT. And I'm going to see how fast this red train will be going to have to cover the 640 miles by itself in the same amount of time. So 640 miles, we don't know the rate, and the time is 8 hours. So I'm going to divide by 8 on both sides, and I'm going to get 640, that should be 80. So this train, to go 640 miles in 8 hours, must be going 80 miles per hour. You see my 80 for my answer? Hey, wait a minute. 80 miles per hour. We've got 30, and we've got 50. 30 plus 50 is 80, right? 30 plus 50 is 80. Coincidence? I think not. So, I don't know if you get it yet, but what we just learned is when we have two things going towards each other in a straight line, instead of being two separate problems, we can pretend that there's one thing, like one train, add the weights together, and figure out how long it would take. So let's try one. Let's say two cars are, you can't see the words, two cars are 600 miles apart. One car is driving at 20 miles per hour, and one car is traveling at 40 miles per hour. How long will it take before the two cars collide, assuming they're on the same stretch of road heading toward each other? I'm going to use D equals RT. I know my distance is 600. I'm looking for my time. My rate is going to be 20 plus 40, or 60. Remember that two cars heading directly toward each other is the same as one car traveling that same distance by itself. And look at that. They will hit in 10 hours. Sorry, not French for hors d'oeuvres. 10 hours. There we go. It would take 10 hours for them to collide. Pretty easy stuff. And I don't know about you, but I feel pretty smart when I do these. Please make sure you're doing your homework, staying up on it. We will be having a quiz on Friday. Mr. Lawrence signing off. Have a good night, everybody.